this is the first assignment that we're going to have on Google Classroom. And since it's kind of this first week, it's a trial run, we're testing this out. This first assignment is going to be considered a grade replacement. Again, things may change when we get into a routine later next week, but for this week, there's going to be only one assignment, and it is going to be a grade replacement. That means that after this lesson, if you complete this assignment, which is on Google Classroom, you complete it entirely, send it to me, email a picture, whatever you gotta do, that will be a grade replacement for any of your previous assignments that are now in the grade book. So if your lowest grade is a 3 out of 10, I'm going to go through it. I'm going to replace a homework grade with a 10 out of 10. If your lowest grade is a 1 out of 10, you get a 10 out of 10 if you finish this. If your lowest grade is a missing assignment, i.e. you have a 0 somewhere for a homework grade, I'm just going to go replace a missing assignment. I'm going to replace a 0 with a 10 out of 10 if you complete this assignment, all right? If your lowest grade is an 8 out of 10, it's 10 out of 10. That's how it works. I'm going to go through some problems that are going to be very similar to that homework, so get ready. Some of them are actually going to be on the worksheet, so if you want to have the worksheet ready with you, or if you want to start ready, go through, write down the questions you can determine later, however you want to do that. Let's just get started though. Goodness. All right. This first one says graph the exponential function. You have f of x equals 3 times 2 to the power of x. And let's just kind of break this down real quick. I know we've been talking about like every exponential can be written in the form a times b to the x, where a is your initial value. So my initial value here, I know it has to be 3. And then this 2, or this kind of b value that we talked about, this is our growth or decay factor, what number we're multiplying by every time, right? So to graph this, kind of like what we've been doing, this is just review, all right? Review for this first week. I'm just going to make a table of values so that I can plot all of these points to graph on my coordinate plane. So in my table, I have a whole bunch of x values going from -2 to 2. We could extend this out, but let's just get a general idea of what this graph looks like. So if I plug in -2 into f of x, so if I'm technically finding f of -2, so this is going to be 3 times 2 to the power of -2. All right, let's break that down. 2 to the power of -2, I see a negative in the exponent. We talked about kind of flipping my fraction here. So that 2, it's in the numerator now, it has to go to the denominator. So this is going to be 3 times 1 over, I have to flip that down to the denominator, 1 over 2 squared. Since I took care of that negative exponent and I flipped the fraction, that square is still there. That just takes care of the negative. So then I could say, you can think about it, what's 1/2 squared or what's 2 squared? Well, 2 squared is just 4. And then 3 times 1/4, we're just going to say that it's 3/4. All right, we'll graph that later. We'll kind of eyeball it. Let's do the same for the rest of these numbers. So if I plug in -1, I'm going to have 3 times 2 to the power of -1. Same thing with that negative exponent here. That's going to flip my fraction. So I'm going to have 3 times 1 over 2. And since I have an exponent of 1, it's just 2 to the first power. So we're kind of done, right? And then if I want to simplify that down, well, 3 times 1/2 is just going to be 3 over 2 or 1.5, all right? The next one, if I plug in 0 into my function, I have 3 times 2 to the power of 0. We know that anything to the power of 0 is just 1. So this is really just 3 times 1, which, oh my gosh, you guessed it. It's our initial value. It's just 3. Okay. Quickly, let's plug in 1 to the power of 1 times 3. Well, that's just 3 times 2, and that's just going to give us 6. And then our last one, 3 times 2 to the power of 2. That's 3 times 4, and that gives us 12. Now we have a whole bunch of things that we can graph, all of these points here. I'm going to highlight. The first point is going to be at -2 3/4, right? And our second point at -1 3/2, 0 3 1 6. I'm just getting these right off of the table. So I'm going to go graph these real quick off to the side. -2, so I go out to -2 and then up 3/4, I'll call it right there. So my first point, about right here, -1 and 3/2, so -1, 1.5. 0, 3, that one's easy, right on the y-axis. 1, 6, and then 2, 12, that's kind of way off. Put a dot right there, we'll call that good. So my exponential is going to look something like that. And then we have some questions below that are going to ask us. Again, these are the same type of questions that are on that worksheet, all right? So it's just stepping you through this stuff. What point is the y-intercept / initial value? Well, again, we can kind of get that from our formula. It's got to be that 3, and I know that my initial value is wherever x equals 0, and I know x equals 0 right here, and if I follow that point up, it's at 0, 3. So my y-intercept is at 0, 3. My initial value here is just 3. Is this thing growth or decay? Hopefully you can answer that it is growth, right? Because our numbers are getting bigger. I see this curve going up. So this is exponential growth. And now that I know that it's growth, I'm asking what is the growth factor? Again, that's what we're multiplying by every time. I'm multiplying by 2 every time, all right? I'm doubling. So my growth factor is indeed 2. All right, so that was that first one, just being able to make a table of values, graph an exponential, answer a couple questions about some of its key features. Let's move on to the next one. We're doing good. We're doing good. All right. This guy, Scott, buys a tractor for $15,000. The value of the tractor depreciates. We have this kind of fancy word. We've talked about that before. Depreciates at a rate of 5% every year. How much is the tractor worth after 10 years? These are the same questions that I give you on this worksheet. All right, so let's kind of go through these real quick. What's the initial value? That's kind of my starting point, right? I'm starting with a cost of $15,000. Oops, $15,000. Is it growth or decay? It says that the tractor depreciates over time, and hopefully, obviously, our tractor, unless we're polishing every day or whatever, tractor worth is going to be going down. So depreciate means decrease in value. We do have a decay problem, so this is decay. What is the percentage rate? Oops, what is the percentage rate? We've got 5%. And 5% as a decimal, we move the decimal place of this percentage over twice. So 5% as a decimal is 0.05 because I have to put that placeholder 0 right here. And then it asks, would we use 1 plus r or 1 minus r? If you remember, we kind of had this basic formula for every exponential, and I'm going to write this off to the side. We had several different forms. We used different letters for it, but basically it was like an amount A or whatever times your initial value or principal, which we usually stood for P, 1 plus or minus r to the power of t to the power of time. And inside was 1 plus a rate or 1 minus a rate. And these directly go with growth and decay, right? So 1 plus r would indicate growth because then this growth factor in here would be bigger than 1. But since we're using a decay problem, we're using a decay exponential, my decay factor has to be less than 1. Therefore, we have to use 1 minus r. All right? So we're going to use 1 minus r. Let me go back to red. And then it just says find the value after 10 years. So this is just plug all of your information into this formula right here. All right? So we're trying to find the value after 10 years. Sum of value A equals my initial amount. That's too many zeros. No, it's not. All right. 1 minus my rate as a decimal, 0.05, to the power of t, and this time after 10 years, there we go, I put t time 10, ooh, they all start with t, up into the exponent. All right, let's get on track. I'm kind of losing my brain here. So this right here is just a number. Evaluate that down. 1 minus 0.05, and that's going to give you 0.95 raised to the 10th power. This is stuff you probably want to do on your calculator. If you raise 0.95 to the 10th power, You're going to get a crazy decimal. Let me write that all out, going step by step here. 0.95 to the 10th power is 0.5987. And dot, 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 it keeps going. And then finally multiply those together. You're going to get a price roughly at 68,000, what do we got? 854.748. All right, so after 10 years, we do see that tractor value depreciating, decreasing. All right. If at any point you need to go back and do something. All right. Go back and rework through these at your own pace. Kind of going quick on these. The last two, I put these nice fancy stars next to them because they are directly from that worksheet. So again, if you just want to take the work that I'm doing here and keep working on it, I'm doing some of them for you, all right? This next one says, using our exponent rules, which expression is different than the others? We had a couple of these in class where we used our exponent rules to either prove and show that all of our expressions were the same, or to show that there was one that didn't match up with the other ones, all right? And we kind of had these exponent rules. You can just Google exponent rules. It should be like the first picture that pops up. Let's look at some of these. I'm going to do one with you, and then I'm going to expect you to do the others and show me which one doesn't match. I'm going to take a look at this one right here, all right? I have 50 times 2 to the power of x minus 1. If I can show that that expression is similar to any of the other three, then I can start connecting these links, right? And I can show which one doesn't match. So I notice up in my exponent, I have subtraction as an operation. So I'm going to go visit my exponent rules and see what does it mean when I have subtraction in my exponent. Let's see. Here we go. Subtraction in my exponent right here with the quotient rule. It says that if I have some a to the power of x minus y, that means that what I'm doing is I am dividing the same power of a. So I'm taking a to the power of x divided by a to the power of y. I'm going to go apply this to the original problem real quick. So we could think about these as like our x and our y value right here. I'm going to cancel that out. So what this is really saying is that I'm taking, that 50 is still there. What it's saying is that 2 to the power of x divided by 2 to the first power is the same thing as 2 to the power of x minus 1. All right, I'm kind of going backwards with that rule. If you need, pause and take a minute, make sure that makes sense. All right, shoot me an email if you have questions. So let's kind of work with this a little bit, because now I have something that I can work with. I've got this 50, and I have this 2 in the denominator here. Well, I'm going to write this as, well, if I can get my marker, there we go, 50 divided by 2. I'm just kind of taking that 2 to the power of 1 and I'm moving it on the outside of my parentheses. And now I can say, all right, 50 divided by 2, well, that's just 25 times 2 to the, times 2 to the power of x, right? Hey, does that look similar to anything else? Yes, it does. Over here, I've just connected these two. All right. So now I know that these two are the same. Show me that either this one doesn't work or that this one doesn't work. All right. That they're not the same as the other ones. Use your exponent rules. All right. I'm moving on to the very last one. We're going to go through this one real quick because this is what we last left off on. Again, this is one that comes right from the worksheet. It says, given 2 points, one of them being the y-intercept, find an exponential function that goes through both of the 2 points. We had some steps for this. First, can you write out, we know, let me write this out. We know every exponential is in the form a times b to the x, where this is our initial value and this is our growth factor, growth or decay factor. So if we could figure out our initial value, well, and if one of them is already a y-intercept, where x equals 0, At this point, when x equals 0, my y value is 3. So right there, my initial value is 3. I can replace a with 3. So I know the function that goes between these 2 points has to look something similar to y equals 3 times some growth factor b to the power of x. So this is kind of like our bare bones equation for these 2 points. Next step was to plug the second point in and see if we can solve for b. We're going to have to use some like square roots or third roots, right? So I'm going to plug my second point in. My second point is 2, 3/4. So to my x value, so that's going to be my exponent. And my y value, 3/4, that's going to be my y value right here. So I've got 3/4 equals 3 times 2. Oh, I'm sorry. Let me switch those up. B to the power of 2. All right, so I've just plugged that point in, and now I have this. Okay, now I got to solve for b. So I can divide by 3 on both sides to get rid of this 3 right here. And dividing by 3, just for notation's sake, I'm going to do it this way. Dividing by 3 is the same thing as multiplying by 1/3. So I'm going to multiply by 1/3 on both sides to get rid of this 3 here. So multiplying by 1/3, I'm going to multiply by 1/3 on both sides. That 1/3 and 3 cancel each other out. So on the right-hand side of the equation, I'm just left with b squared. On the left-hand side of the equation, I have 1/3 times 3/4. And if you think about it, these 3's are going to cancel out because one of them's on the numerator, one of them's on the denominator. And if you want to think about it, off to the side, I'm going to do this. I'm going to say 1/3 times 3/4, and that's going to give me 3/12, which is going to reduce down to 1/4. So I see now I'm just left with 1/4, all right? So now I have 1/4 equals b squared, and we talked about getting rid of this exponent of 2. I need to take the square root, all right? Since I have 2 up in the exponent, I'm going to take the second root, right? We talked about taking, if there's an exponent of 5, you would take the 5th root on both sides with your calculator. So I'm going to take the square root of both sides. You could plug this into your calculator if you want, or you could think about it. Well, square root of, if you want to think about it, square root of 1 is just 1, right? And square root of 4 is just 2, so 1/2 has to be my b value. And again, my square root and my square cancel each other out, so I just have b equals 1/2. Now I can put this all together. Oh my gosh, we're almost done. Hang in there. As my final function, y equals my initial value of 3 times my b value of 1/2 to the power of x. There you go. That's the function that we were looking for, all right? Try the second one on your own. You're going to see that you're going to have to take the 4th root on both sides. Hint, hint, all right? Again, this assignment, it's our first week. We're just doing a review. This is review. This is a grade replacement assignment, so complete this. Send it to me in an email, and I'm just going to go replace your lowest grade, whatever it is. If it's a 0, I replace it with a 10. If it's a 4, I replace it with a 10, all right? Thank you, thank you. Have a great day. Go team!